Howdy, folks. This is G from Tone Empire. Hope all of you are doing well. So today we've got our very first guest on our channel. Yes, I have got a guest. And there's a reason for getting this guest on. He's a very, very dear friend, a very close collaborator on some of our plugins, and genius overall. His name is Jatin Chowdhury. Jatin is basically a DSP expert coder and has done some breakthroughs of his own. He actually has his own company called DSP. You can check it out. I'll leave the link in the description below. The reason I've got Jatin onto this channel and this episode is for some specific reasons. So Jatin, being an expert, will answer some of the questions that you ask me. You ask me things about AI models and oversampling on AI models and why certain things are. See, since we're entering this new era of new machine learning type of plugins, things and concepts have changed. Things we used to think about, take for granted, are gone, yet new things have appeared. So the way that digital audio moves forward is going to be with new technologies and some new changes. And here's a person that I ask these relevant questions to, and he very gladly answers and is very generous with his time and with his knowledge and information. I thought that it would be a great idea to bring him on board directly and ask him some of the questions that you ask us on Facebook, on YouTube, on some of our emails. So I thought this is the best way to just put out some good DSP information out there. We want to be authentic. We want to be people who are open to listening and learning. So there are many things that Jatin says in this video which enlighten me more, hopefully enlightens all of you, and you go home a little technically richer and hearing from the horse's mouth, as I say, not by just generally popular people who have some ideas of how things work, but really from people who actually make things along with me and then him. And this is a way of getting someone else to bring their perspective into the mix and for all of us to learn. So here goes our interview with Jatin. I hope you enjoy. Thank you. Empire channel, and our audience would be very, very pleased to meet you because you're the real deal. So, as I mentioned on my channel, that Jatin has been a collaborator on our previous projects. He's done, parts of stuff which are very important to our line of plugins, especially the Relight plugin, the original one, where some part of the saturation modeling and all was done by Jatin, and some of the IR stuff and all. And then recently we've started launching a new line of plugins which are AI and machine learning based. So I have got the guy for you who has made a system which reads these models real time and puts them there for you to use actually on a real time basis. So he has a large contribution in that. Today we're going to speak to Jatin about many of the mysteries and things, because we get a lot of questions based on what these AI models are really, how they work, how they are different really from their regular algorithm processors. So let's start, Jatin, and but before we start with these questions, I just want to just introduce your own brand. So Jatin has his own plugin company which is called DSP. I'm sure most of you have heard of it. He has a lovely tape plugin there himself, and it's actually available for free. Is that correct?
Yes, it's a free plugin.
Awesome. So go to that site, check out his plugins and the brilliant work that he does. So Jatin, just tell us a little bit about your technical background, and our audience would love to know.
Sure thing. Yeah, and thanks so much for having me on the channel. It's really exciting to be here. So I started out kind of as an electrical engineer. I was doing electrical engineering as my undergraduate degree, and kind of at the same time I was also doing a bit of work with mixing and mastering and music production in general. And then I was very fortunate to be accepted to a program at Stanford University as part of their Karma program that was specifically focused on music technology. And yeah, that was fantastic, fantastic opportunity for me. I got to learn a ton from Julius Smith and from a lot of the other professors and students who were there. And yeah, that's kind of where I started.
That's wonderful. So see, the same thing, like, having a musical background, but also having a very well established technical background, and especially in DSP, and certain breakthroughs that you're doing are really remarkable. So, Jatin, in your journey, you've been doing the audio DSP thing for how long now? How many years have you been into this?
Oh, maybe 5 or 6 years.
5 or 6 years, yeah. That's pretty substantial. And, with your own line of products and working with other manufacturers, it's pretty incredible. So I'll get straight to one of the, important questions. Is that, a lot of our users keep asking us that, hey, why don't you have additional oversampling as an option in, your machine learning based plugins? So I have had many answers, but I think coming from the horse's mouth or coming from a person more technically qualified than me would be, better chance for even me to learn why this is so. So could you comprehensively answer for our audience why we don't have that?
Sure thing. So I guess the real answer is the advantage that you would get from oversampling would depend on what type of network architecture you're using for your neural network. But kind of the fundamental issue that you run into, not even necessarily specific to oversampling, but more in general with neural network audio effects, is that when you train the neural network, you're training on some audio that is at some sample rate, whatever the person recorded it at. And so then when you go to actually use the audio effect with that neural network, you have kind of this weird situation where the training data was at some sample rate, but the data that you're trying to process with your audio effect might be at a different sample rate. So maybe the training data was recorded at 48 kilohertz, but you're running your DAW at 44.1 or something like that. And so different network architectures have different ways of adapting to that sample rate mismatch. But probably the most common thing that most folks are doing is you just resample the incoming audio to whatever the sample rate of the training data was. Then you run your neural network, and then you resample back to the DAW sample rate. And so in that case, oversampling really doesn't give you anything because you're just going to resample to your training sample rate anyway.
Perfect. So that was the answer that I've been trying to tell people, but I guess coming from you, it kind of authenticates it. That's great. Another kind of question we get, which is not related really, I think, to AI, but is that the calculations at which the plugin performs, so 32-bit or 16-bit or 64-bit, people have started demanding like a higher bit systems, and because some of their mixed buses have obviously, the DAWs have expanded and now they have that facility. So I want to know, what is the real relevance in this? Is this really going to affect the audio quality if one starts approaching higher bit systems?
Yeah, that's a tricky question. So in general, for recording audio, kind of the rule of thumb that I had learned was that I think you get like, I feel like it was like 6 decibels of dynamic range per bit or something like that. So the folks that I had worked with when I was learning my recording techniques were saying that like, oh, if you have 32-bit floats, then your dynamic range is like 130 decibels, and that's way larger dynamic range than anyone can hear, right? So they're like, okay, you don't really need anything more than 32-bit float, and that's true for recording. For processing, it depends a little bit on what kind of processing you're actually doing. So there are some processes that are numerically sensitive. And for example, maybe you can't even run the process in a way that's stable with a 32-bit floating point number. You need the higher precision to be able to keep the computation stable. That definitely happens. So yeah, there's some different things around that. In particular, if you're using bi-quad filters or things like that as part of your process, the extra precision can definitely help, because the kind of precision imperfections that you get from the multiplies in your filter will accumulate the more you run the filter. And there's some different filter architectures that can help with that as well. But kind of the trade-off that you get is with performance, because if you're trying to do block processing or something like that, most CPUs these days have instructions that can do an operation on 4 or 8 32-bit numbers at a time. And so if you go up to 64-bit, now the instructions will only operate on 2 or 4 numbers at a time. So it'll be a little bit slower. So it's kind of a trade-off that you have to think about as far as performance. Am I using an algorithm that needs this extra precision? Things like that. So it is more specific to the kind of task the plugin might be performing. It could be like completely unnecessary for certain other kind of things, which just kills your CPU, but really does not provide a kind of massively audible result. But like you say, maybe in a chain of things or in a cumulative kind of processing, eventually it will help. Hopefully, or when the CPUs try to get better also, which they already at a great point, there will be a time where it will be more valid to probably
implemented. But as of now, I personally, as a manufacturer, I stay away from that because I'm like, most of the customers we have also want CPU-friendly systems. So, like you said, it's a bit of a question of where you need it. Just put it where you just avoid it. Because I mean, let's face it, digital audio has its limitations. It's not very analog. So,
of course, yeah.
So aliasing again just becomes such a strong factor, which of course it's an artifact, and hopefully one wants to, reduce it as much as possible in a plugin. But sometimes, I mean, just talking from a user point of view, 90% of people don't care about it, but there are certain 10% who I do understand, and we can't ignore, who approach their mixing process with a kind of technical validation. They need that validation before they want to go for it. So will digital audio after heavy processing ever be completely aliasing free? I pose that question. With heavy processing, say like on heavy compression, smashing the sound, or super distortion that's happening, is it ever going to be aliasing free? There's the question.
Well, I guess it depends what you mean by aliasing free.
Like behave like analog, have absolutely no pushback harmonics and things like that.
Yeah, I mean, in any digital audio, even if you're not doing any nonlinear processing at all, even if all you're doing is recording some analog sound source and you're putting it into your DAW, you're always going to get some aliasing. Even the best anti-aliasing measures, all they can do is reduce aliasing by, hopefully 100 decibels or more. So, depending on what level of precision you're looking at things, you're always going to see some aliasing. It's kind of unavoidable. The trick is, or the question is, how much can we suppress it, right? Like most good audio interfaces or A to D converters will have, a really good brick wall filter and, a really good D to A converter that can pretty much get rid of most aliasing artifacts that, you would be able to hear. And so it's kind of a similar question for nonlinear processors, where obviously there's going to be some aliasing, but if we can make it, minus 100 decibels, minus 120 decibels, things like that, then at that point I would say it's aliasing free. So that's kind of the goal. And we're getting closer. I think it's really cool that, maybe 10 years ago, kind of the only way to reduce aliasing was to do oversampling. And obviously that puts more stress on your CPU. And so I think it's really cool that in the past 10 years, we've seen more algorithmic improvements where we have different ways of doing your nonlinear process that can reduce aliasing without necessarily having to do oversampling. And you can also do oversampling. So if you combine some of these, newer ways of doing a nonlinear process with oversampling, then you can get a really good result and get really low aliasing, which is
correct. I mean, I think it's like the same, exactly what you're saying is that's the goal, but different manufacturers have different methods. I mean, in many cases, the filtering also has to be like really good, but you don't want to compromise. Like I see or hear in certain other manufacturers' plugins, they really use like a filter going right down to 15 or 12 kilohertz. And that just is getting rid of the, high end, but just in order to prove that their plugin is not aliasing so much. And, people get fooled by that also. I mean, I said, but you can hear the complete change in the, in the sound, like the high end is gone. So, without, or some people do some weird kind of stuff where I've heard it is that, they will identify the key resonant points and, have steep filters, notch filters, like clean that out. But that sounds so phasey. And, just for that fight or this, this show me a graph and I'll show you who you are kind of attitude. And yeah, I mean, I fight that on a daily basis. But like I said, there's no permanent solutions. Do we want to improve aliasing? Certainly. But, at what cost becomes the question. But like you said, that there are smarter processes which are not just going to be oversampling, which can help, with that. And by the end of the day, this is important. I'm not saying it's not. But trust me, the artists we have on our Tone Empire and Beat Skills, catalog or the repertoire, who are actually doing, I think, probably work which is known. I'm not saying that by any means it makes them superior to other people, because that's just a by chance thing. But these people are just working. And if I ever ask about these questions to you, says, are you kidding? I don't care about all of this. We're just, if it sounds good, it's good. Let's move on. So I mean, it's a different thing. It's like invalidating all the records which came out in 1990s and 2000s, which were 16 bits. Like, I think we got to put them out of commission because they have incredible amount of aliasing on them. Oh, why did this sell? So anyway, I mean, like you said, it's a compromise, and bringing you on, this is a very important thing, I think, because I also learn. I'm not saying that my way of thinking is the best. You having a perfect balance of actually being more DSP oriented, more technically. Obviously well-read and well-educated is a good thing, to bring you on and have your opinion, because it's not biased by me in any way, and I appreciate that. There's certain other questions I wanted to ask, in terms of, Apple is coming out with the silicon processors which now have neural cores.
Mm-hmm.
So where do you think neural cores could play a part in future plugins, and do you think it has any advantage that we could use and take?
Yeah, definitely. Yeah, I mean, I think that this is something I was talking with someone a week or two ago about. How can we take advantage of this new hardware that's available? And yeah, it's definitely very exciting, because kind of the idea is that you have some hardware that is specifically wired to do certain operations very quickly. So certain matrix multiplications and vector operations that your neural networks need to do a lot of. Your CPU can do a pretty good job with them, but the CPU is more designed for general purpose computational operations. The neural core, I forget exactly what they call it, but that specific piece of hardware is designed specifically for doing these operations that you need to do quite often in a neural network. So yeah, it's very exciting, and it's very cool that people who are making hardware and putting them in consumer computers are making this available to everyone. And I hope that continues. The difficult part of it for audio is kind of figuring out how to make use of this specific hardware without introducing issues that, particularly when you're thinking about making a system that is real-time safe, you don't want to have to wait for the hardware to do something. You want to have a very well-defined length of time that it's going to take for me to put some data or send some data to this piece of hardware and get a result back. And again, I have to look a bit more closely at how this is implemented exactly in Apple's system. But yeah, obviously it's very exciting, and I think it opens up a lot of opportunities for people who want to put neural networks and plugins and do things that are sort of on the cutting edge like that.
Awesome. So my final question to you is about AI and machine learning trained systems as they're coming through, and we're getting better with deeper dilations and more convolution layers and things like that, versus the original circuit modeling technology. I guess we were talking about this some time ago, and we were talking about a project you're doing where you just felt that you just couldn't do without a certain component being trained with a neural network, get more authentic results. So could you tell us your perspective on kind of AI versus circuit modeling?
Yeah, exactly. So I think it's a really interesting question, and these are sort of both areas that I spent a lot of time on, both doing sort of I guess what you would call white box circuit modeling and using neural networks to model circuits. And I think they both certainly have a place, and they're not necessarily opposed to each other in a lot of ways. So the great thing about white box circuit models is that you know exactly, or you're using your knowledge of the system to create a model of it. So if you know how a certain component works, you can just do exactly what that needs to do in your model, and you'll get your result. And that's really nice, because then, if you know how a resistor works and you can have that in your model, then if you have a knob or some control that is controlling something in your circuit, then that's just a variable resistor, and it's very easy to include in your model. With a neural network approach, it's more of a black box circuit model where you don't really have to know about any of the internals, right? You don't need to know any of the physics or things that are going on to make the circuit sound the way it sounds. All you need is some data, and you can record some training data, and then you can train your neural network. And in a lot of ways, that's cool because sometimes there are things, even if you understand the physics of even if you understand the physics of the circuit that you're modeling, sometimes there are components that behave in non-ideal ways or don't match exactly the way that the physics equations say they should behave. And this is specifically true of certain types of audio circuits where they were kind of designed around the fact that in certain conditions, certain components behave in weird ways. And so neural networks are great at capturing that stuff and being able to kind of get these specific things that are either impossible to model or very difficult to model with these physics equations. And because we're able to train them in a way that is kind of perceptually defined, even if you're using some approximation compared to what's actually going on in the physics, the approximation is tuned so that it sounds close to what you're expecting it to sound, what you're expecting it to sound like. And so, yeah, it's kind of an interesting balance where, if you want to have more controls in your circuit or in your circuit model, the white box model is usually better. If you want to just have accurate capture of these certain parts of your circuit that don't behave perfectly, then the neural network's usually better. And there's kind of a trade-off between those. But something that Julius Smith used to say that I always think about is he would say, I'm forgetting the exact phrasing, but it was something like ideal signal processing is always ideal. And so kind of the circuit modeling interpretation of that is that if I know exactly how a resistor works, my neural network that is trained to model a resistor is just going to, like, if it trains perfectly, it's just going to give me the exact same thing as a perfect physical model would, right? So if I know the physical model, then I think that the white box is best. But of course, knowing all the things you know to get the physical model right can be difficult. And then finally, I think the thing that maybe excites me most right now is kind of combining the neural network approach and the circuit modeling approach. So for example, this was a paper that my friend Chris and I worked on about a year ago, where we had some circuits that had a lot of linear circuit components and a few nonlinear circuit components. And kind of our idea was, what if we have a circuit model where all of the linear components are modeled using traditional circuit modeling methods, and then the nonlinear components have a neural network trained to model just those components. So the idea is that the parts of the circuit we understand well and have manual controls over, like knobs and sliders and things like that, we can use the traditional physical model for that. And then the parts that are nonlinear and behave more in a more interesting way, we can use neural network just for that stuff. And so that sort of achieves a nice balance of really good accuracy, getting something that sounds really close to the hardware, but also has a lot of control. You can also have a lot of controls over it, and also has really good CPU performance. So that's, to me, that's kind of the goal.
Correct. I mean, whatever, like you said, technology works. Like right now, if you were to do like a black box model of a white box, means go every component neural, the processing would go insane. So like you're saying, what are the parts?
Necessarily. You can use really small neural networks for the simple components.
Okay, awesome. So there you go. There's a new learning for us. So certainly, I think the main takeaway is that even what we are doing with the company is that we are starting the modeling of a certain hardware, which is kind of rare but has fewer controls. So that's there. But like the white box gives you the possibility of detaching certain things like the compression with the saturation, but the neural model captures everything as you hear it. So in many cases, the user response actually has been that, with our LVL1 plugin or with the TM700, recently we released the tape machine, which is, a model of the tape machine I have, is that people found a certain amount of realism that they quote is kind of better than what they've heard before, especially in the tube distortion and all. So, I mean, I hear it too, but again, like, it's a matter of, psychological or what's real. Nobody can't tell. I mean, it could just be something influencing the other. And we also try to check ourselves on that. But certainly, this magical power for not having to collect like a bunch of scientists and, opening up a circuit, getting schematics and, getting down with the equation and just, sampling something, the power of doing that. I mean, that is certainly extremely exciting and tempting. And it's very creative because also like, I could do chains of things. I could have maybe a knee VQ and some kind of a compressor chain and create kind of a sound which might have less controls, but gets you there real quick and is kind of authentic to, what the analog counterpart is. So I think certainly it has a place, and with your work, it's become real-time accessible. I think the challenge we used to have with our Python scripts earlier and all whatever we were trying was the things were non-real-time, and you just broke that barrier. So we're all very grateful to the work you've done. And then again, I thank Martin also. He's another associate of ours who's further expanded on that and the training and whatever, and have broken certainly some boundaries with which we come out with our systems. And hey guys, I don't want to take this too long. We'll definitely get Jatin again on our channel, and I hope you got to learn a lot from this really intelligent and progressive gentleman. But do go check out his own website also, which is Chowdsp, and check out the plugins. He has a lot of freebies, and you can get to know more about Jatin. He also shares a bit of his code and stuff on GitHub. If you guys want to try and start your own thing, go there, and if you can manage to put it together and use it, do mention his credits and put him through. So thank you again, Jatin, for your time today. I really appreciate it. I think definitely our audience will go a little more technically and emotionally richer with this particular video. So
thank you for having me on.
Yeah, my pleasure. We'll have you on again another time. Thank you so much. We'll see you guys in another video. Ciao.